Good morning, students. So today we are going to discuss the properties of colloidal solutions and their applications and where we can see colloids around us. So this will be the last topic of this chapter. So let us start. Okay, now see the next property of colloidal sols is electrophoresis. Okay, the next property is electrophoresis. Now see, in electrophoresis, when electric potential is applied across two platinum electrodes dipping in a colloidal solution, the colloidal particles move towards one or the other electrode. The movement of colloidal particles under an applied electric potential is called electrophoresis. Positively charged particles move towards the cathode while negatively charged particles move towards the anode. Okay, now see what is electrophoresis. It is the process of movement of colloidal particles towards electrodes under the influence of electric current. Now see, as we know that colloidal particles have some charge. Okay, now when we will put electrodes in a solution of colloidal sol, then one of the electrode will be positively charged and another will be negatively charged. So whatever is the charge on colloidal sol particles, those particles will start moving towards the oppositely charged plate, and this movement is termed as electrophoresis. Now how it appears, you can see here, this is a U-tube and here we have fitted two electrodes. This is cathode which is connected to negative terminal of the battery. This is anode which is connected to positive terminal of the battery. Now see, suppose it is a colloidal solution and it is a colored solution, suppose, then color is because of the presence of colloidal sol particles. Now when we will apply current, when current will be passed, then they will move to one of the electrode. Now in this figure we have shown that the particles are moving towards anode. It means they are moving towards positively charged plate. So it means those particles carry negative charge, or we can say this colloidal sol is negative sol. Okay. Now whatever is the color of the colloidal sol, we will see that when current is passed, then at a particular electrode there is more concentration of the ions, so that will look too much dark. That color will be seen very dark there, and on the other end it will be very light, or it may be considered as zero. Okay, so from this migration we will come to know what is the charge on the colloidal sol particles. If we don't know what is the charge on colloidal sol particle, then by the process of electrophoresis we can determine the charge on a particular colloidal sol. Okay. Now one more property is coagulation or flocculation or precipitation. So precipitation word is known to you, coagulation and flocculation is something new. So these all have the same meaning. Okay. Now what is the meaning? The process of settling of colloidal particles is called coagulation or precipitation. Okay. Now how we can make a particular colloidal sol to settle down, because it is stable. So how it is done? When excess of an electrolyte is added, the colloidal particles are precipitated. Now why colloidal particles are precipitated? Because of the addition of electrolyte. What is the reason? The reason is that colloids interact with ions carrying charge opposite to that present on themselves. This causes neutralization, leading to the coagulation. Okay. Now what we said? We said that since we know that in the colloidal sol particles there is some charge, so when we are going to put a particular electrolyte in that, then what will happen? Electrolyte contains both the ions, positive ions also, negative ions also. So out of the two, one will be responsible for neutralization of the colloidal sol particles. Suppose colloidal sol is carrying a negative charge and we are putting sodium chloride electrolyte, then sodium ion will be responsible for the coagulation. okay, because it is carrying positive charge and that charge is opposite to that of the charge on colloidal Soul particles. Okay, so what is the simple reason? That oppositely charged ions present in electrolyte neutralize the colloidal Soul particles, and so they fall down or they settle down at the bottom, and this settling down is known as coagulation or flocculation or precipitation. Okay, so now this is clear that if we have a negative ion, then it will cause precipitation of positively charged Soul, and if we have positive ion, then it will cause coagulation or precipitation of negative Soul. Okay. Now there are few rules which determine the process of coagulation. Those rules are known as Hardy-Skulls rules. So there are two rules only. First rule is ion carrying charge opposite to that of colloidal Soul particles is called active ion. Now just now I said that if we are taking a negative Soul, then those ions which are carrying positive charge in the electrolyte, they will be responsible for its coagulation, and those ions will be termed as active ions. Okay. Now this is the very first point. Now second point is that it has been observed that generally the greater the valence of the flocculating ion or coagulating ion or active ion, the greater is its power to cause precipitation. Okay. So what we will say, that if there is a negative Soul and we are using sodium chloride, then sodium is carrying charge 1 positive. Okay. Now in place of sodium chloride, if I use barium chloride, then there is production of barium ion, and barium ion is having charge 2 positive. So it means it will have more effective process for flocculation or for coagulation. So this flocculating power or coagulating power is directly dependent on the valency. Okay. So what is the rule? That power of coagulating ion or flocculating ion is directly dependent on its valency. For example, if there is a negative Soul, then if we are using 3 different electrolytes, then the electrolyte in which positive charge is more in the ion, that electrolyte will be more effective. So we have to use less, okay, for total coagulation. So in this case, if aluminium, barium and sodium ions are to be used, then order will be aluminium is greater than barium is greater than sodium. Similarly, in case we are having a positive Soul, then negative ions will be the active ions. So now see, if we are using a salt or electrolyte in which this is the negative ion formed, then it will be most effective because there is 4 negative charge, and this will be lesser effective than this because there is 3 negative charge on this. This will be still lesser effective because of 2 negative charge, and this will be the least effective because of -1 charge. Okay. So this is what decides the coagulation. Okay. Now one more thing. What do we mean by coagulating value? What is the coagulating value? The minimum concentration of an electrolyte in millimoles per liter. Just like we say concentration in moles per liter, here we are saying millimoles per liter, required to cause precipitation of a Soul in 2 hours is called coagulating value. So what standard we have chosen? We have taken any particular colloidal Soul, and now we are using different electrolytes. That electrolyte which uses the minimum amount, that will be termed as the active ion with maximum coagulating value. Okay. So what is the result? Smaller is the quantity needed, higher will be the coagulating power. Okay. So if certain ion is having more power, then that will be used in less amount. Okay. Now one more thing, how can we coagulate a lyophilic Soul? Now why we are discussing it in a separate manner? Because lyophilic Souls are very much stable. Okay. So if we want to coagulate lyophilic Soul, then how it is possible? Now why these are so stable? There are 2 factors which are responsible for its stability. What are those two factors? One is charge and another is solvation of the colloidal particles. Solvation of colloidal particles means that colloidal particles are surrounded by water molecules and that gives it more stability. Okay, more molecules attached means more solvation. Okay, now if by some method we can remove these two factors, then it means lyophilic sole will become unstable and it will get coagulated. Now how these two factors can be removed? Now what we do, first of all we use a particular suitable solvent. Okay, first of all we will be adding a certain suitable solvent. What that solvent will do, that solvent will result in the dehydration of dispersed phase. Dehydration of dispersed phase means its extent of solvation will decrease. Extent of solvation will decrease means more molecules will not get attached to the colloidal sole particles and lesser molecules will get attached to it. So that will give it less stability. Okay. Now once this thing happens, then we will add a electrolyte. We will add an electrolyte. When electrolyte is added at this condition, then this will bring out the coagulation of lyophilic sole. Okay. So here only thing is that lyophilic soles are very much stable. So how to coagulate them? This was the topic. Okay. Now can we protect a colloid also from coagulation or no? Now this is the topic. Okay, now see, when out of these two soles, lyophilic and lyophobic, lyophilic are more stable, just like just now we discussed. They are more stable than lyophilic soles. Now why they are more stable? Because they are extensively solvated, that is colloidal particles are covered by a sheath of the liquid in which they are dispersed. Means that dispersion medium, those molecules cover our colloidal sole particles very properly. Okay, and because of this they act as protection. Okay, now lyophilic colloids, they have unique property of protecting lyophobic colloids. Okay, now see, if we have a lyophobic colloid, then what we will do, if we want to protect a lyophobic colloid, then we will add little amount of, if we want to protect lyophobic sole, then we have to add little amount of lyophilic sole in that. And what it will do, this lyophilic sole particles, they will form a layer around the lyophobic particles. Okay, now once they form the layer, then in case we are adding some electrolyte for coagulation, then what will happen, those active ions will react with lyophilic soles first. They will react with lyophilic sole particles first because they are covering the lyophobic sole particles. Okay, so in this way, if we will add a little amount of electrolyte, then it will not result in coagulation. But in case we add too much, then what will happen, once all the lyophilic colloid sole particles are neutralized, then the number of lyophobic sole will come. Then those molecules which are forming lyophobic sole, they will start coagulating. Okay, so means this protection is for addition of little amount of electrolyte. Okay, for little amount of electrolyte addition, this colloid, hydrophobic colloid, will get protected because of the addition of little amount of lyophilic sole. Okay, now that particular colloid which we are using to protect a lyophobic sole, that is known as protective colloid. Okay, what do we say? It is a protective colloid. Now one more type of colloidal sole which is termed as emulsion. Now what are emulsions? Now as we know that there are two components of colloidal sole. So one is dispersed phase, another is dispersion medium. In case both components are liquids, then they will form a colloid which is called emulsion. Now they are of two types, oil in water type. Now oil in water means water is in more amount, oil is in less amount. So whichever is less, that is called dispersed phase, whichever is in more amount, that is called dispersion medium. So oil in water means oil is dispersed phase and water is dispersion medium. But if we say water in oil, then means water is dispersed phase and oil is dispersion medium. Okay, now let us discuss with example. If we talk about milk, then water is in more amount, so water is dispersion medium, and fat is in less amount, so fat or oil is dispersed phase. So it is an example of oil in water type. Now if we talk about butter, okay, then oil is the dispersion medium and water is the dispersed phase. Okay, so these are examples of emulsion. Now here you can see, if we are talking about oil in water, then it means oil will be less and water will be more. If we are talking about water in oil, then it means water will be less and oil will be more. Okay. Now one thing comes to our mind, that oil and water are immiscible in nature, then how come they can form emulsion? So the answer to this problem is that we have to use some emulsifying agent. Okay, only then these emulsions exist. So oil and water is one thing. We have to add little amount of some stabilizing agent. That stabilizing agent is called emulsifying agent. Now what it does? Emulsifying agent forms an interfacial film between suspended particles and the medium. Okay, now see what emulsifying agent will do. Just like this is our oil. So it will form a layer around this. Emulsifying agent will form a layer around this. This layer, what it will do? This layer will not let these two molecules come together. In case these two molecules come together, then they will come together, they all will come together and they will form a bigger molecule, and that bigger molecule will start settling down, and at last it will settle down and there will be two layers. So these do not combine. For doing that, what is done, an emulsifying agent is added that makes a layer around the dispersed phase particles and does not allow all the particles to come closer and form a bigger molecule and get settled. Okay, so this is why emulsifying agent is used. Now let us discuss where we can see in our daily life colloids. Now very first thing, blue color of the sky. Okay, we know that in air what is there? Dust particles are present, then water molecules are present, they are suspended in air. What they do? They scatter blue light which reaches our eye and sky looks blue to us. Now we know that this light is made up of 7 colors, so it scatters blue light and we can see blue color of the sky. Okay. Now second is fog, mist and rain. Now these are all interrelated terms. Okay, now see, when a large mass of air containing dust particles is cooled below its dew point. Now see, suppose there is such situation that whatever air is there that gets cooled below its dew point, then what happens? The moisture from the air condenses on the surface of these particles. Okay, there are dust particles. What moisture will do? That will start condensing on the dust particle. Dust particle will act as nucleus and the whole moisture will be surrounding it. Okay, and so these fine droplets of water will be formed. Okay, now these droplets, what will be their nature? They will be colloidal nature. Their nature will be colloidal nature and they will start floating in the air, and when they are floating in the air we will feel mist or fog. Okay, now when we talk about clouds, what are clouds? Cloud is also a type of colloid and this category is aerosol. Okay, now there is what is there in clouds? There are very small droplets of water suspended in the air. Okay, now On account of condensation in the upper atmosphere, the colloidal droplets of water grow bigger and bigger in size until they fall in the form of rain. Means what they are saying, that cloud contains water droplets, and those water droplets are dispersed in air. Okay, so when these clouds move upper and upper, there is the process of condensation. Okay, now because of this condensation, what happens, these small droplets of water, they start coming closer, and because of that they form bigger and bigger molecules, and when the size of molecule becomes too big to be remain suspended in air, then it falls in the form of rain. Okay, sometime what happens, when there are two oppositely charged clouds, they come together, then they attract each other, and because of this attraction, these water droplets, they become bigger and bigger, and they fall in the form of rain. And sometime it may cause cloud burst also. Okay, which is very dangerous. A lot of water will come at once and it may damage something. Okay, now one more thing which we can learn from here, that if somehow we can neutralize the water droplets present in the air in cloud, okay, then they will fall as rain. So artificial rain is also possible. How it is possible? Because clouds are colloids, and we know colloids can be coagulated. So we have to do something which results in coagulation of cloud. So how they can be coagulated? By the use of electrolyte. So if we spray a soul carrying charge opposite to that of charge on cloud, from where we have to throw? We have to go above the clouds, and then we have to throw on the clouds. That particular electrolyte will neutralize the dispersed phase particles on the cloud, and they will fall as rain, and this will be termed as artificial rain. Now blood, sometime you might have seen that while we shave, we get cut, and at once we use a piece of alum and we rub it, we wash it in, we dip it in water, and then we rub it on the skin, and at once we are able to see that there is no blood coming out from the cut. So how it is possible? Now what is blood? Blood is a colloidal solution of albuminoid. Okay, now when we apply alum, then what it does? It does the coagulation of blood. So when there is a cut, then at that particular place we will rub the wet alum. This wet alum will coagulate the blood at that particular opening, and this will prevent, this will cause this clot will be formed over there, and that clot will not allow further bleeding. Okay, so this way this alum is used for stopping this bleeding. Okay, now one very important use, formation of delta. You might have seen, might have learned somewhere in history or somewhere that Sundarban delta is the most fertile land in India. So what are deltas? How deltas are formed? Now see, whenever there is some stream of a river, that water carries with this lot of minerals. Okay, and when it comes at the sea, when it comes near sea, what happens? In sea there is dissolved salt. Okay, sea water is salty. So those salts which are present in sea, they act as electrolyte, and this river is bringing so many minerals dissolved in water, which is acting as colloidal soul. So those particles get coagulated at the point of junction where these two waters meet, river water and sea water. Where this water meets, there they get coagulated and they settle down at the bottom. Now when this process goes on for so many years, then there is formation of a piece of land. That piece of land formed is called delta. And now see, since this piece of land has formed by the coagulation of minerals only, so it is very much fertile. Okay. Now, where this colloids are applicable? Now, this is very important. This is corporeal smoke precipitator. Now, see what is there. You might have seen in factories there is a chimney, and from that chimney a lot of dark fumes are coming out. So those fumes, they can be refined, or whatever carbon is coming out from that particular chimney, that can be tracked there itself, that cannot be allowed to go out by the use of corporeal smoke precipitator. So what it does, now when we talk about the black clouds which are coming out of the chimney, they are also colloids. Okay. Now since they are colloids, now why they are colloids? Because there is a dispersed phase carbon and dispersion medium is air, so they are also colloids. Now if they are colloids, then it means there is presence of certain charge on them. So if they are charged, then they can be easily coagulated. So what we do, we fit this particular apparatus in the chimney. Okay. And we allow our carbon containing smoke to pass through this apparatus and then to leave. Now what is there in this apparatus? In this apparatus there are charged plates, there are oppositely charged plates. Now see, this is a particular high voltage electrode. Here there will be some plates, they will be oppositely charged to that of charge on the smoke. So whatever is the charge on smoke, oppositely charged plates, what they will do, they will attract the dispersed phase particles present in smoke, and those particles will get coagulated here itself. Okay. So because of coagulation, they will fall down and we can collect them, and then whatever gases go out, they do not contain carbon. So carbon content can be removed from the smoke coming out from the chimneys in the factories. Okay. So this is very important application of colloids. Okay. Now one more thing, tanning. Okay. Now see, when we buy something made up of leather, so that leather is not exactly the one which is obtained from dead animals. When we obtain something from dead animals, that skin, their skin, which is to be used for leather goods and all, so that particular leather, which is raw leather, we must say raw leather, that raw leather is not that much hard. Okay. So what we do, that particular raw leather is colloidal in nature. Okay. Now what we do, we take a particular substance called tannin. There are other substances also, but tannin was the most widely used, so this process is also termed as tanning. Okay. So what we do, that particular raw leather is of colloidal nature and that has positively charged particles. Okay. Now it is soaked in tannin solution. What we do, we make tannin solution and we soak that particular raw leather in that. Now what it does, this particular colloidal this particular solution, what it will do, it will do the process of coagulation. Okay. There is presence of positive and negative particles. Whatever is the charge on that raw leather, opposite is the charge on the solution. Okay. Which solution? Tannin solution. So when we will dip that raw leather in a tannin solution, then on the surface of raw leather, process of coagulation will occur. Okay. Now when process of coagulation occur, just like you saw in the bleeding case, there was formation of clot, and which prevented the further flow of blood. So similar is the case here. Raw leather is soft. When we soak it in the solution of tannin, then what happens, due to the process of coagulation, it becomes hard. Okay. and when we take it out, then it is quite hard, and now it can be processed for further leather use. Okay, so this process is called tanning. Okay, now see, chromium salts are also used in place of tannin, but tanning name is given because in the beginning tannin was the substance which was used. Okay, so it is given, otherwise, or there are so many other substances which can be used for the process of coagulation. Okay, now last, purification of drinking water. Now see, sometime when we get water which even if we filter, there is presence of that appears not so bright, but it appears dull. So that dullness is because of very minute particles of dust which are distributed evenly, and they are forming a colloidal solution. Now what is to be done? What we will do, we will put a small piece of alum, or we will take alum, we will crush it in a particular packet, and that packet will be moved throughout the solution. Okay, and what it will cause? It will cause those suspended impurities or suspended dust particles to settle down, and then that water will become clear. Okay, now we have finished this chapter. Whatever we have discussed today, on the basis of that you have to solve these home assignments. Okay, thank you.